Friends, welcome to my YouTube channel. Today I am going to discuss simple impulse turbine problem. So already derivations, velocity diagram, how to draw the velocity triangle and how to write the formula. All those things I discussed in the previous video. So now I taken one question. What the question they are asking? So following data refers to a single stage impulse turbine. So they given the single stage impulse turbine. Steam velocity they given. I wrote V1 symbol, steam velocity 600, given 500. So 500 meter per second. Given steam velocity 500 meter per second. Blade speed given 200 meter per second. Alpha given nozzle angle will be 20 degree. So 20 degree. And exit blade angle symbols I took a 25 degree. Mass flow rate 5 kg. Then given neglecting the blade frictions. Neglecting blade frictions means relative velocity will be equal both inlet and outlet. Relative velocity will be equal both inlet and outlet. That means neglecting the blade friction. So generally, simple impulse turbine, blade velocity will be equal. Blade velocity will be equal because we are considering no friction during the flow of the steam through the blade. But generally, suppose frictions will be there, they will give the K. K is nothing but friction factor. VR2 minus VR1. If the K they will give, that means VR1 will be greater than VR2 will be there. Otherwise, neglecting blade frictions means blade will be smooth, then VR1 equal to VR2. VR1 equal to VR2 will be there. So, okay. So, this is a given that I wrote. How to attempt the questions. So, before this we have to draw the tentative velocity diagram. So, tentative velocity diagram here see already we kept. This is inlet triangle, this is outlet triangle. Inlet triangle means steam enters into the nozzle at steam velocity V1, some angle. And exit angle will be beta, V2. VW2, this one vril velocity at outlet, vril velocity at inlet. Now inlet blade angle enters with the relative velocity and outlet will the relative velocity phi. So inlet blade angle, outlet blade angle. Now both inlet and outlet triangle will combine together first. So how to draw? Already we draw here, but how to draw we'll see here. This first inlet triangle will draw here. Inlet triangle will draw first. So inlet triangle means this nozzle angle alpha will go the vertical line. This angle is alpha. Now if we'll join some blade angle, will blade and distance this na. This is the theta. This is inlet blade angle. Then this total length, this will be VW1 vril velocity at inlet. This is the blade velocity. Just we are taking VB, small VB. Actually blade velocity will be, both will be equal. Once will combine, see this part, blade velocity will be equal for inlet and outlet. So okay, now theta, inlet blade angle. Outlet blade angle coming from the inlet blade angle. So this will draw this line. This lines will draw. Then what will be the beta angle? Something either acute angle. If beta, first we'll assume beta will be acute angle less than 90. Then we'll draw some angle. Tentative. These are the drawing the tentative. We'll draw the vertical line. This will be the VW2. This will be the vril velocity at outlet. This is flow velocity outlet. This is flow velocity at inlet. This is relative velocity inlet, steam velocity. This is relative velocity outlet. This is V2, steam velocity outlet. So this we draw. Inlet blade angle. This is phi, outlet blade angle alpha, nozzle angle, inlet, nozzle angle, outlet. Everything we draw. Now what we'll do? We'll separate all the triangles. First alpha triangles we are separating. Why we are separating this? Because if you see this formula, if they are asking axial thrust, work done, inlet blade angle or tangential thrust, whatever. So all the formula you will see the velocity will be the unknown. Velocity will be the unknown. So all the velocities will be there in this velocity triangle. Now we'll separate all the triangles. First we are taking the alpha angle. This is the alpha. Why I am taking first angle? Because alpha given 20 degree and V1 given 500 meter per second. So this is VW1, this is VF1, this is V1. See this? We take an angle. Suppose you will give the name A, B, C, D, E, F. So what is this one? Alpha angle BDC. BD, take this small d, BDC, BDC. So DC, VF, BD, VW1, BC, V1. Now, always this information they will give because steam enters into the nozzle. Then steam enters through the nozzle means some angle should be there. Then some steam velocity will be there. This two always this data will be there. Suppose this angle is there when a hypotenuse is there because this is right angle triangle. Right angle triangle. This is the angle. So this VW1 is base here. VW1 is base here. By the Pythagoras theorem, what will the sine alpha here? Sine alpha equal to P by H. P by H. VF1 by V1. So sine 20 degree I know. Sine 20 degree. VF1 we don't know. V1 we know 500. If we'll get the VF1 nothing but sine 20 into 500. Sine 20 into 500. So we calculated the value. Sine 20 into 500, 171.01. 171.01 meter per second. One value I know. Then VW1 we should know. So then again what will go here? Cos alpha. Cos alpha. Cos alpha equal to B by H. B by H. So what will write here? VW1 by V1. So again here cos 20. Cos 20 because alpha given 20 degree. Alpha given nozzle angle 20 degree. VW1 we need. Then V1 is 500. So VW1 will get nothing but here 500 into cos 20. 500 into cos 20. So that value will be 469.85. 469.85 meter per second. So cos 20 and into 500. You will get this value. So now first triangle work over. BDC one triangle work over. Now if we will see the another triangle. If we will take the another triangle, theta triangle. See here. Because 4 triangles we can take out. Alpha triangle, theta triangle, phi triangle, beta triangle. 4 triangle is there in the velocity diagram. So theta taken. Then what is the side? This one VF1. This is nothing but VR1. This length how much? CD. 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 A, B. This is E. This is E, no? So this is E. A, B, C, D, E, F. So E this one. So C, D, E. So C, D nothing but VW1 minus VB. So what is this one? VW1 minus VB. So all those things, all side I wrote. Now what is known here? VW1 I know, VB I know, VF1 I know. So that means this is P, this is B. P, B we know. So we'll go the triangle 2. This suppose the triangle 2 taken. This is triangle 1. So triangle 1 taken this 2. This 2 taken from the triangle 1. This 2 we taken from the triangle 1. Now from triangle 2, tan theta. Why we will take tan theta? Because P and B we know. Perpendicular and base we know. So P is nothing but VF1 by VW1. VW1 minus VB. All the value we know. VF1 we know 171.01. VW1 we know here 469.85 0.85 minus VB 200. So tan theta will get. Then theta equal to tan inverse this value. This value how much coming? We'll see, we calculated here. Tan theta value we are getting 0.634. 0.634. So we'll write here 634 point. So this angle will get. Angle how much we got? 32.37 degree. 32.37 degree. So inlet billet angle. That also they are asking. What they are asking? First one is, what is the inlet billet angle? This first one they are asking inlet billet angle. One answer I know now. Inlet billet angle. So two triangle here. In this triangle, VR1 is unknown. So again we'll do this. So this part I am going to rub it now. This part before the solving the question, this triangle and all you have to draw. So what is the informations I given here? That also you look here. But for that particular problem, this is not there. But what is the cases will come? See, what is the possible formula here? Tangential thrust na m Vw1 plus minus Vw2 Newton. Unit is Newton. Why unit is Newton? Because mass unit is kg per second. Velocity meter per second. So kg meter per second square will come. Kg meter per second square is nothing but Newton. So this unit is Newton. So tangential thrust mass into velocity, real velocity at inlet and velocity at outlet. Plus minus I given. Why plus minus I given? You listen here. This plus minus depends upon this angle beta. Depends upon the angle beta. If beta is acute angle, that means less than 90. If beta will be acute angle, this is less than 90, Vw2 will be positive. Vw2 will be positive. See, it's coming this side now from B to A, positive. Because beta is acute angle. So that case Vw2 is positive. So formula will give the positive. Wherever give plus minus, formula will be positive. If beta is equal to 90 degree, that case also they will give in case of axial discharge. In case of axial discharge, that means beta will be 90 degree. If beta will be 90 degree, this line will be vertical line. Suppose you look here. Suppose this is the triangle we drawed. This triangle we drawed. Now beta is equal to 90 degree. Beta is equal to 90 degree. This line will be 90 degree na VF2, V2. So this line what will come? This line nothing but V2 or VF2. Both will be equal. So I wrote V2 and VF2 will be equal when beta will be 90 degree. In this case, V2 will be 0. Vw2 equal to 0 because no length. Because here will be VB, here Vw1, but no Vw2. So in that case, Vw2 will be 0. Now look here. If beta is more than 90, now this lines will come, suppose here. Then if you will draw the vertical line, this is the Vw2. This length is Vw2. Vw2 coming inside. So Vw2 will be negative. So that time formula will be negative. 90 degree V2 will not come. V2 will be 0. And if beta is more than 90, now this line will be there. More than 90, now these lines will be there. You see the different color. If more than 90 will come now, suppose this is the line. More than 90, then it will come here. Draw the vertical line. So where will be the draw the vertical line? So this VR2 will come. This is VR1, VR2. Where VR2 will meet together, draw the vertical line. This length will be the V2. So again you see here when it will be positive, when it will be the more than 90. So look here. This is the triangle. Now this is the beta equal to 90 degree. Now beta is equal to more than 90. Beta is more than 90. Then we will draw this line here, VR1, VR2. So whatever the phi angle, what is theta angle, whatever the phi angle, draw the vertical line. This length will be Vw2. This length will be Vw2. This Vw2 will be negative. If this perpendicular, Vw1 is 0. If acute angle, that is Vw2 will be the positive. So positive negative meaning is this only. So this concept, suppose separate different problem will be there in the conditions they given, that only we will find out. Okay. So now in this particular questions, beta is given, not given. So we'll see what is beta is coming here. This velocity diagram is tentative diagram. Tentative diagram. What actual diagram will come after solving the questions, we can find out. Okay. So now this part I am going to rub it. All the formulas is here. So once we'll use the problems, we'll write the formula. So these all the cases for the concept already given in this previous video also. Formula I am keeping here for reference. Okay. Now look here. Two triangles are taken. Now we'll take the another triangle. What is CAF? What is the triangle? CAF. So CA what is? VW2 plus VB. VW2 plus VB. This is VR2. This is VF2. This is the VF2. Now I taken this triangle. Now what informations I know before this? So the given here condition neglecting the blade friction. So VR1 equal to VR2 we know. So VR1 we don't know. First second triangles we have to find out what is VR1. So P by H. So if we'll take from second triangle sin theta is equal to P by H. VF1 by VR1. So theta we know. Sin 32.37 is equal to VF1 is 171.01 divided by VR1. So VR1 will get from here. VR1 will get from here. So how much VR1 we got here? For these calculations I know. VR1 we got 319.41. 319.41 meter per second. So VR1 we know now. VR1 we know now. Now, given the conditions, VR1 equal to VR2. So that means VR2 you know. VB, this phi angle given. Phi angle how much given? 25 degree. Phi angle given 25 degree. Exit blade angle. So angle the given VR2 we know. VR2 know. So we'll take again sin phi. If we'll take sin phi, what is? VF2 by VR2. So sin phi how much? Sin 25 degree is equal to VF2 I need, and VR2 nothing but 319.41. So that implies VF2 will know now. VF2 we can find out here. How much we calculated? VF2 we calculated anywhere 134.99. 134.99 meter per second. So now you know VR2. Once you know the VR2, only VW2 we don't know. So we'll take the relation either P by B, tan phi or cos phi, whatever. So we'll see, we'll take cos phi. You can say tan phi also, nothing wrong. Cos phi na B by H. What is B by H? B na VW2 plus VB by H. VR2. Cos phi, cos 25 degree equal to VW2 we don't know. VB is equal to 200. VB is equal to 200 given. So 200 given here. And VR2 you know. VR1 equal to VR2. So 319.41. So how we'll calculate here? This into this. So see here, we can calculate, here we'll write cos 25 degree into 319.41 minus 200 is known as VW2. If this we'll see here, this and this cross multiplication, cos 25 into this, then V2 plus 200 will be there, then 200 will come this side minus, so VW2 will be how much here we are getting? VW2 we are getting 89.484. 89.484 meter per second. So all are the velocity. So all are the meter per second unit. VF2 we know. Now we'll check what they're asking. So the triangle, what purpose will you use this all the triangles? For the finding the unknown velocities. All are the right angle triangles. So we know sine, cos, tan, everything we know. Now we'll see what they're asking. First one is axial thrust. Axial thrust anywhere is there? Axial thrust. M Vf1. So first one, axial thrust. Axial thrust, what they're asking? M Vf1 minus Vf2. So M they given 5 kg per second, yes. And Vf1 given how much? Vf1 we know 171.01 minus Vf2, just now we got it 134.99. So we know the axial thrust here. Axial thrust calculation is 180.1 Newton. So 180.1 Newton. Now we know. Tangential thrust they are not asking. If they will ask, we will substitute this formula. M Vw1 plus Vw2, all the either. But these questions they are not asking. Okay, axial thrust over. Now work done. Inlet blade angle over. Work done they are asking, or power. Work done per second or power. What is the formula for this? 2 Vw1. Now we'll take only plus. Why we'll take plus? Because here beta is acute angle. So Vw2, then blade velocity by steam velocity at inlet. Always we'll take kinetic energy, steam velocity at inlet only. So that what is the work done? Work done into blade velocity. That means tangential thrust into blade velocity is known as work done. So this is the formula for the work done. M Vw1 plus minus Vw2 Vb. This is power will not come, no? So M. So this is power only. Power M Vw1 plus Vw2 into Vb. This for diagram efficiency we are writing. Okay. Now we'll substitute the value. M is equal to 5. Vw1 how much? 469.85 plus Vw2 89.484 into 200. So this velocity will come. This means work done per second will come. Watt. How much watt will come? Work done per second we calculated anywhere. So 559.334. 559.34 watt. 559.34. It will come kilowatt. Big value will come. So it is coming kilowatt. If we will calculate this plus this into 5, it's coming 559.34 kilowatt is coming. So okay. So power we know now. This also we know. Now what is the diagram efficiency? Diagram efficiency nothing but work done by kinetic energy. So this will be the diagram efficiency or blade efficiency. Both are same. Or sometimes they'll ask stage efficiency. So what is the formula? 2 Vw plus Vw2 into blade velocity by inlet velocity, inlet steam velocity. So this is the formula, work done by kinetic energy. So work done by kinetic energy we know. Now we will substitute all the value. What we'll get here? 2 into Vw1, same thing, what is 469.85 plus 89.484 into 200 blade velocity divide by V1 how much? 500 whole square, steam velocity 500 whole square. So 85 into 89, so how much coming this value? 89.5%. If this will calculate, it will come 89.5%. So this way we can calculate. So what we observe here, take the given data, draw the velocity diagram, take all the 4 triangles, alpha, theta, phi. Suppose they want beta, they want other angle information, so we'll take 4th triangle also. Then which triangle will start first? So generally, if steam enters into the blade by the nozzle, then some angle should be there. So nozzle angle 20 degree. Then steam velocity will be there. These two always will be there. Blade velocity also sometimes they will give. If blade velocity they will not give, blade velocity formula is pi dn by 60. Dia of the nozzle they will give, speed of this give, then Vb we can calculate by this formula, but this formula directly VB given, so we used that. So based on this, all the velocities we'll find out and we'll get the, we'll substitute the value for the formulas, because all the formula only velocity is unknown, and we can calculate the all the unknowns value. Now you look here, if this is the analytical method, just I will give the little brief for the graphical method here itself. So what is the graphical method, I will show here itself. So it will take only 2 to 3 minutes for graphical, and same things we can substitute. So if we'll go the graphical method, what we'll do here, see, graphical method we'll see now, this GRPHI, graphical method. This what we did before, this is called analytical method. Graphical method, now what we have to do, we have to draw first horizontal lines you draw. See how simple. First one, draw the horizontal line. We draw the one horizontal line. Now, in this point, what is the nozzle angle given? 20 degree. Nozzle angle given 20 degree. So here we'll draw the, by the protector. Protector will draw here the 20 degree. So here we'll draw the 20 degree. 20 degree we'll draw here. And we'll draw the line of the 20 degree. We'll draw the line 20 degree. Now, so look here, alpha given 20 degree, V1 given 500 meter per second. 500 meter per second. These things will have it. 500 meter per second. And blade velocity given 200 meter per second. So already we know this is V1. So V1 500 meter per second, we cannot take the distance. So we'll use the scale. Use the scale. So scale means we proper scale. So if scale we use 50 meter per second is equal to 1 centimeter we'll use. If we'll use na, then this will come 50 divide panana 10 centimeter. This divide na 4 centimeter. So what we'll do here? We'll cut from there 10 centimeter, because this alpha we draw 20 degree. Alpha we draw the 20 degree. Now from there we'll cut the 10 centimeter. So we draw the then we'll draw the 10 centimeter. Suppose I'm taking that value. Suppose this is 10 centimeter. Now draw the vertical line. What is the property of this our tentative triangle? This is there na. Draw this line. This is the vertical line. So we draw this. Now from here to here 4 centimeter. What is this one? 4 centimeter will take. This is the VB given. 200 meter per second, 4 centimeter is cutted. Now what is this? We'll join these two. If we'll join these two. Now look here. VF1, this is VR1, this is VB already 200 meter per second or 4 centimeter. This is VW1, this is the theta. Now all the angle will measure. Suppose give the name I given, what is B, C, D, E. So now see, we given the name now BD. What is BD here? BD here VW1. How much centimeter? If you measure it will come how much centimeter? VW1 will come 9.4 centimeter. VW1 will come 9.4 centimeter. If you measure DE, nothing but VF1 will measure from the scale. VF1 we will get VF1 will get 3.5 centimeter. 3.5 centimeter. Then theta will measure from the protector. So theta will get how much with theta we got 33 degree. If you measure, you are getting the 33 degree. Now next what we'll do? We know the theta and phi angles they given. Phi angle they given how much? Phi angle they given 25. So this is 20 degree. So 25. This is 25 degree. We'll make here. Now you know CE VR1 equal to VR2. VR1 equal to VR2 given. So CE, how much CE? We'll cut this. How much CE? CE VR1 equal to VR2 will cut. We'll draw the vertical line. This is B point. We draw the vertical line. We'll join this. Then we'll join this. All those things over here. So this is VR2. So VR1 equal to VR2. This is V2. This is VF2. Now we'll measure distance. Suppose this is given BC. Suppose this is A. This is F. Now AB. AB how much coming here? VW2 is 1.8 centimeter. If you measure V, 1.8 centimeter. Then AF. This is nothing but VW2. This is AF nothing but VF2. So VF2, how much centimeter we got here? 2.7 centimeter. 2.7 centimeter. Any other things? Beta will get 50. Beta will get here 56 degree. If we measure this beta, we'll get 56 degree. So we draw the graphical method, the velocity diagram. Now, same formula we have to substitute. But what is the VW1 here? Into 50. Into 50. How much coming? 9.4 into 50? 470. 470 meter per second. 3.5 centimeter into 50. VF1. 3.5 into 70, 175 meter per second coming. Now, 1.8 into 50. 1.8 into 50, how much getting here? 90 meter per second. 90 meter per second. 2.7 into 50. 2.7 into 50. It will coming 135 meter per second. So all the velocity you know. In the schematic diagram, what we are doing? VF1, how much? 171.01. Here VF1, 175. So this schematic diagram will be the exact method. Graphical method is approximate method. VW1, 469.85. 470. Now theta 32. Theta we are getting here 33 degree. 33 degree. Remaining other things, VR1, where is the VR1? So this VR1 I not measure. So VR1 will be, it will come 6.4 centimeter. VR1 if you measure 6.4 centimeter into 50. Here into 50, 320 meter per second. 320 meter per second. So if you measure CE, 320. So what is here? 319.41. So VF2, 134.99. VF2, 135. VW2, 89.484. V2 is equal to 90. So this will come our whole number velocity. Now all the velocities, again you will substitute the formula, you will get the answer. So schematic method, what you have to do? All the triangles, draw the triangles, use the Pythagoras theorem, sine, cos, tan, we find all the velocities unknown and substitute the formula. Graphical methods, what we have to do? Start the nozzle angle. 20 degree. Draw the velocity, steam velocity, 500 given knot. Use the scale 10 centimeter. Cut this. Draw the vertical line. Then take the blade velocity 4 centimeter. Draw this line. So you know theta, you know VF1, you know VR1. Then theta is equal to 5 given here this question. So draw 25 degree given 5. So 25 degree make here, draw the line. Cut C equal to this CF. Then draw the vertical line. AB is VW2, AF is VF2, BF is V2, beta. All those things will get. Whatever required in the formula, substitute and get the answer. So this is the graphical method. Graphical method means this all the value will become approximately the schematic methods. Okay. Okay students, watch this video carefully and share this video to your friends and revise twice and thrice, then you will get the concept. Okay. Thank you.